The first step of MIMO state feedback control is to perform the so-called Luenberger type normal form. The Luenberger type normal form has a similar aim as the controllability normal form, the diagonal normal form of the observability normal form in the CISO system. So it's a kind of normal form which has got some advantages, and the advantages of the Luenberger type normal form is shown in these lectures. So the first step is to repeat the matrix B. The matrix B is at U, so the input of the system. The matrix B has got some columns, and the number of the columns is R. And in this case, we have got R independent inputs, and it is very important to highlight that the number of the independent inputs is R. It means that we have got R independent column vectors in the matrix B, that is, the rank of the B is equal to R. Why is it so important? If we have got, for example, 1 or 2 or 3 inputs which are not independent to each other, it means that input is not independent, so we don't need that input. That's why it is very important to realize a system model which has got R independent inputs. The second step is the controllability matrix. It is the same as in the case of CISO systems. So the first element here is the matrix B. The second is A square B, AB, sorry. The third is A square B, and so on. So the number of the blocks is N, and every block contains B and AB and A square B, and so on and so on. So the number of the rows in MC is N, and the number of the columns in the controllability matrix is N by R. The next step is the so-called selection scheme. It's a very important step of the Luenberger type normal form. What is the selection scheme? So if we have got the controllability matrix, we have to move along the columns of MC from left to right, and we have to select the independent columns. Maybe it's a little bit difficult to follow. That's why I think it's a good idea to show the selection scheme and the others in the next videos through a simple example. And in this case, the matrix B here has 3 columns, 3 independent columns. It means that we have got 3 independent inputs of the system, so the value of R is equal to 3. The number of the states is 6, so N is equal to 6. So first we have to perform the controllability matrix, and the first block is the matrix B itself with the 3 independent columns, B1, B2, and B3. The second block is AB. So it means that AB1, AB2, and AB3, so it means that we have got 3 columns more, denoted by with blue letters. The next block is A square B. It means that we have got A square B1, A square B2, A square B3, and so on and so on. The next is A to the power of 3B, and so on. So the last is A to the power of 5 and B. So this MC matrix has more column vectors that appeared here. So let's go through the selection scheme. The first block B is independent. So the B1, B2, and B3 vectors here in this block are independent to each other because it is the first supposition which I mentioned at the very beginning of this page. So I just copy B1, B2, and B3 here in the selection scheme. So this is the selection scheme which I perform here. So next we are in the fourth column. We have to check whether AB1 vector is independent of B1, B2, and B3 or not. Let's say in this example, AB1, this column vector, is independent from B1, B2, and B3, and I just copy it to the selection scheme AB1 to here. The next is the column 5, the fifth column, and I have to check whether this column vector is independent from B1, B2, B3, and AB1. And let's say in this example, AB2 is not independent from these first 4 column vectors, and that means that I have to close the second column of the selection scheme, and I put a circle there. It means that the second column is closed. Now we are going to the sixth column vector, and we are going to check whether AB3 is independent from B1, B2, B3, AB1, and AB2 or not. Let's say in this example, AB3 is independent. It's a new independent column vector, so I put it to the selection scheme. Okay, let's go further. The next column vector is a square b1. So it means that I have to check whether a square b1 is independent from the first 6 column vectors or not. Let's say in this example, a square b1 is independent from b1, b2, b3, ab1, ab2, and ab3, and I put it to this place, a square b1. And now the second column of the selection scheme is closed. That's why a square b2 I don't have to check, because that column of the selection scheme is closed. I go to the next, a square b3, and I am checking it is independent from the first other column vectors or not. Let's say in this example it is not a new independent vector, and I close this block here. And I am going to the next, a to the power of 3b1, and let's say it is not independent. It's not a new independent block, and I am closing this column in the selection scheme again. So this is the so-called selection scheme of the Luenberger type normal form. So in the selection scheme, all the vectors are independent from each other. It's a very, very important thing. So we are selecting the independent column vectors from MC by this technique. So in this case, n is equal to 6, and we have got, as you calculate, 1, 2, 3, 4, 5, and 6 elements of the selection scheme, and it is a supposition in this very simple example. So next, what is the next step? In the next step, we are going to calculate the independent elements of the selection scheme. So in the first column of selection scheme, we have got 3 independent elements. So that's why I'm going to introduce the index sigma. Sigma 1 is equal to 3. Sigma 2 in the second block, in the second column of the scheme, will be equal to 3 plus 1. 3 from the first element, first column, and 1 from the second block. It will be 4. In the third column, we have got 2 more elements. It means that sigma 3 is equal to 4 plus 2. It means 6. So these indexes will play an important role in the next video, so please remember these values. Sigma 1 is 3, sigma 2 is 4, sigma 3 is 6. So it's nothing more than the number of the elements of the selection scheme. The last step here is to build up a matrix, and this matrix is denoted by P. In P, I am just copying the elements of the selection scheme in the following way. So I put B1, A B1, A square B1 from the first column. I put B2 from the second, and finally B3 and AB3 from the third column of the selection rule. P has got 6 column vectors, and this matrix has 6, the number of the rows is 6. So it's a 6 by 6 matrix in this case. One more important thing. P contains the linearly independent column vectors of the matrix MC. And the most important things which I highlight here again is the independent. So P contains independent column vectors of MC, and it means that P always has an inverse matrix because of this, and this inverse matrix is going to play a very important role in the next video. So we are going to continue with these and the indexes.